My God,
Hello,
this
everyone.
always
Welcome
happens.
to the Carolina Weather Group. You gotta love technology. We are live. I can see us live down in our little lower third. So, welcome to tonight's show. This is show number 282. And tonight we have with us Dr. Victor Gensini, Associate Professor at Northern Illinois University. And Victor is no stranger to the show. I think this is his third appearance on our show. So, he's getting up there in the appearance likes here for the Carolina Weather Group. But again, this is the Wednesday, June 26, 2019 edition of a little weather get together. And again, show number 282. So tonight's topic, we're going to be talking about tornadoes. And maybe there's some research coming out that Victor's been a part of that is showing that we are seeing an uptick of tornadoes and tornado probabilities in the Southeast. And that's something we're going to talk about tonight. Maybe how that's going to affect you if you live in the Carolinas and Georgia, Alabama, Mississippi, places like that. So some really interesting information tonight, and we hope that you will enjoy it. And we welcome your interaction. We are live streaming right now on Twitch, Facebook Live, and Periscope. So we'd love for you to interact with us as well as our YouTube page. You can submit those questions via those platforms, or you can tweet them at us at Carolina WX Group. We'll be monitoring those streams throughout the night. And if you have any questions for our guests or maybe even our panelists, as we kind of talk about this upcoming week's weather, we would love to see those. And if you're listening to the podcast version, we'll let Victor give out some of his social media information, some websites that you can find this research at. And if you have any questions, you can direct them towards him. So again, we have a good panel group tonight. We have Chris Jackson back in Columbia, South Carolina, Evan Fisher in Asheville, North Carolina. We have Shay Gibson in Charleston, South Carolina, Jared Smith in Charleston, South Carolina, and I'm here, Scotty Powell here in Morganton, North Carolina. So thankfully, the weather has been a little bit calmer over the past few days. It's been a stormy weekend, and we'll talk a little bit about that later on in the show. But right now, I think I've got the thumbs up that we can bring in our guests. So we'll bring in Victor. So, Victor, welcome to the Carolina Weather Group. We are happy to have you. And we were storms a second ago. It seems like you had a little storm pop up there just over your house.
Yeah, thanks for having me, guys, and congratulations on 280 now. We're getting close to 300. That's a pretty big landmark for you guys. So congratulations there. Yeah, I was trying to get on here, scrambling. I had to reset my router. We had a just straight southeastern style pop-up severe thunderstorm that went right over. It wasn't severe, but it was a pretty heavy downpour right over the house. And power went off for a little bit, so I was struggling to get the router back on and get lined up with you guys. So I'm glad it all worked out.
We're glad to have you. So, Victor, it's been a busy season for you. Kind of talk about, before we kind of get into tonight's topic, recap the last couple of weeks for you. I know you've finished up school as college let out.
Yeah.
You did a little storm chasing. So what's it been like for the past couple of weeks for you?
Thankfully, things are finally slowing down. Really, early mid to late May was the potpourri of tornadoes across the U.S. But it all started in early May. I was down at the Hazardous Weather Test Bed in Norman, Oklahoma. So that's a really great experiment that runs from May 1st to May 31st. Folks from academia, folks from the National Weather Service, so even some public sector forecasters all kind of go down there, and we're really testing the latest and greatest when it comes to numerical weather predictions. So we're testing the new models that will be coming down the pike. So, I'm sure many of your viewers are familiar with things like the HRRR, the high resolution rapid refresh, but some of the ensembles that are coming beyond the HRRR, and testing the new version of the GFS FV3 in what we call a convective allowing configuration. So, there's been a lot of talk about the latest switch to the GFS. How will that work at the convective scale, for example? When will that replace the HRRR? Things like this, because the idea from NOAA is to really create what we call a unified model suite. So anyway, we're down there all May testing those things. I did the second week of the experiment, I think, and then started chasing. I chase every year. This year less than most, but sometimes 10 to 15,000, even 20,000 miles out in the field. And I didn't get most of the intense period in May. I actually started chasing mostly in late May, early June, which was still fairly good for supercell potential this year. And then you know, you guys know how chasing is, up and down the plains, mostly driving. And then came back a couple weeks ago, and I've been starting to pick back up on research again. So this is really for the academic mind. You know, some folks will teach in the summer, but a lot of us are really catching up on our grant work, writing proposals, and trying to get some research papers out the door. And that's really probably going to be the rest of my summer, is really focusing on research. So that's been my life really in a nutshell over the past really 2 months or so.
Chris, I think he went up us there. 20,000 miles for him. We only put in about 5,000.
we did 5,004 in like, I don't know, 5-6 days. So I'm good with it. That was
Yeah. 5,000 is like you know, that's like a 5K for me nowadays.
That's right.
I think the most
I did about 14,000 last year.
That's impressive. Yeah, I think my most ever was, I think, 24, 25K. And that's when I was chasing with College of DuPage, leading the storm chasing trips out into the field. So I don't do that many miles anymore. I think, in fact, this year I'll have to look at the odometer, but I think it was under 7,000, which is pretty low for me.
So, Victor, I know you've been busy over the past couple of months as well, talking about this new research that you and Mr. Harold Brooks was able to finally produce. And was talking about the tornado frequency shifting eastward from the Great Plains. So can you tell us a little bit about that research? Maybe kind of what sparked what sparked or what spurred this research to take place?
Yeah, the motivation was kind of there have been several papers that come out, and this is not any secret. The number of tornadoes, especially strong tornadoes in the United States, has been relatively constant through time. If you look at F0s, they're increasing, and it's mostly a function of reporting and more storm chasers, et cetera. But if you look at F1s, F2s, et cetera, the trend is minimal, if any. It's pretty constant. And so that leads to a different question, which is, okay, well, if tornado frequency across the United States isn't changing very much, perhaps there's trends locally. In other words, we could have a stagnant number of tornadoes in the US, but they could be increasing in one place that's offsetting, right, the decrease in another. And when you start looking at the numbers, they look relatively benign, the trends themselves. But in a climatological context, they're actually pretty large changes, especially over a 30 to 40 year period. And I think my colleague, Dr. Brooks, puts it really, really nicely. This is the difference between a 200 and a 300 hitter in baseball. So if you watch a 200 versus a 300 average baseball player, that's the difference of about one hit per week over the course of a baseball season, 180 games. Okay, so when you're watching baseball as a normal observer, you probably can't tell the difference on a weekly basis between a 200 and a 300 hitter. You're just not paying close enough attention to that. But at the end of the season, right, we all agree that the 300 hitter is better than the 200. And I think that puts it so nicely that these changes that we're seeing of maybe one tornado per decade, one F1 per decade in Alabama, Mississippi, Tennessee area, that increase is so small, but you have to really look at the data hard to be able to kind of see those changes. So it doesn't really matter at the city scale or the county scale, but if you're aggregating counties together and you're looking over very large areas, the change is pretty climatologically significant when you look at the relative probability of having an F1 tornado, you know, say roughly 25 miles of a point or so. So the changes that we're seeing are significant. And as you guys are aware, tornadoes in the southeastern United States are a big deal from a vulnerability perspective, right? And my colleague, Dr. Walker Ashley at NIU, has looked at this extensively, as well as Dr. Stephen Strader at Villanova. We have more mobile homes in the southeast. We have more trees. Storms tend to move faster. They happen at night more frequently. It's just a perfect recipe for a tornado fatality or tornado disaster. You know, that this is really the crux, I think, in my opinion, of Vortex Southeast, or this should be the crux. It's a social science, part physical science, but mostly social science issue that a lot of really, you know, good research is focusing on now, finally.
Yeah, so Victor, you're talking about those larger areas. Can you kind of give us an idea of what states are included in the more classic tornado alley, whereas, you know, what states are in Dixie Alley and more in the Southeast?
Yeah, good question. So, I mean, if you look at the seminal paper on, you know, what I would consider a tornado alley, at least climatologically defined, it's Brooks and Doswell, 2003. It's basically north central Texas through central Oklahoma, central Kansas, and then kind of takes a shiftward east as it gets up to Nebraska, cuts across the I-80 corridor, and kind of ends really roughly just west of and southwest of Chicago. Now, the southern extent of that, which a lot of people forget, that even paper showed that significant tornadoes in that C shape happen eastward in their extent through places like Shreveport and into Mississippi and portions of Alabama. And, historically speaking, the southeastern United States is no stranger to strong tornadoes, including violent tornadoes. So, it's not a surprise that tornadoes happen there. It just seems to be that in some locations in the Southeast, they're happening there with a little greater frequency than they did, say, in the late 70s. And that's really, I think the study a little bit sort of got shifted in the media with some of the stories, right? People were emailing me, asking me, are you basically saying that tornadoes are never going to happen in Texas and Oklahoma again? Well, that's of course not true. They still happen there with the greatest frequency, actually. It's just that compared to 40 years ago, the numbers of F1s are down slightly from where they used to be. And again, this is not, could it go back in the next 30 years? Absolutely. But it took over 30 years worth of data to be able to even see that trend, because the year-to-year variability, as we've seen the last 4 or 5 years, can be so significant. So it really does take a pretty long climatological record to be able to really diagnose some of these trends.
If we think about that more locally for us here in the Carolinas, has there been like a pretty, or at least a statistically significant increase across, I guess, eastern North Carolina and South Carolina, where they see the most tornadoes?
I'd have to look at the Carolinas specifically. If I remember right from my paper, y'all down there are basically in the increasing, but it wasn't statistically significant. And if I remember right, that ended up being like one F1 per 20 or 25 years was about the threshold cutoff. So, over the course of one person's lifetime, that might equate to maybe 2 more F1s in a 32 kilometer grid box. So not necessarily like a significant change, but when you look at the relatively low probability of tornadoes in those areas, you're still talking about a pretty significant trend upward. And I'll just say that I have a lot more confidence in STP, the significant tornado parameter that we analyzed, versus significant, the rating of tornadoes themselves, which is obvious, as you guys know, a very subjective process where people have to go out and basically, have to determine how strong tornadoes are. And that gets really sticky prior to the 1970s when graduate students were basically looking at photographs, trying to figure out, they weren't even in the field. We just had photographs and they were trying to figure out what the damage rating was. So the tornado, and again, we could spend a whole show on the tornado database and how, the issues with it, but it's the best that we have and we try to do with it, the best that we can.
Yeah, and just building off that, Victor, I just want to go into a little bit. Have you guys noticed, you personally or your research team or any of your research that you've done, noticed a discernible difference over the past 3 years, really since the 2016 tornado season, of a more uptick of, I guess, messy setups to storm chasers, where you have a lot more high precipitation supercells. You don't have the classic tornado outbreaks. Mm-hmm. With that, what do you think may be the cause of? Is more amplified troughs or what?
Yeah, that's a great question. Any answer would be total speculation from me. Subjectively, I will agree with you that it seems that there has been less on the side of classics and actually more LPs and more HPs. So kind of going pulling away from the middle classic towards the ends of the spectrum. That would take a radar-based climatology to, figure out the answers to those. Certainly, if you think of what we're expecting as we go forward the next 30 to 50 years with climate change and some of the models that we have, we would expect probably more HPs with a decreasing strength in the jet stream. But this is actually you're going down the exact path where our research wants to go, which is continuing to try to figure out what are the major drivers of variability from year to year. So, for example, what makes an April 2011 versus an April 2013 or 2016? And we think we have some of the answers to that, but not all. And then what are we going to expect by mid-century with supercells? Is Nebraska and the Dakotas going to become the new Texas, Oklahoma, or is it going to be the Canadian prairies? Or are we going to see a relatively, what we see now, with maybe just messier storms, as you say? Will they be more intense updrafts because of greater CAPE? A lot of studies suggest that instability will be increasing by late century, with maybe an offset in wind shear. So there's a lot of questions that I think a lot of people want the answers to, and we just don't have them right now. And when you don't have the answers, you do research and try to figure out the answers, and that's really what we're going to continue to do here. At least my 10-year plan at NIU in terms of research is really try to answer some of the questions that you guys are answering or asking.
Yeah, it's just so fascinating. Like you've got these storms that develop, and they may develop as an LP or even a classic supercell, but all of a sudden they just tick, and then they grow, get this high precipitation core, and then they start growing upscale, and before you know it, you have an MCS. And just to see in the field and to see it happen on radar, it's pretty spectacular. And just want to get your thoughts on it.
I agree. We actually my only funding right now from the National Science Foundation is with Dr. Ashley to actually look at the changes in MCS frequency, because in the summertime, the precip, the most important precip is actually the precip that happens from mesoscale convective systems to recharge, say, the Ogallala Aquifer in the high plains of Nebraska and Kansas. And so we're really interested in how MCSs may change as well. Are they going to grow larger, become more efficient rain producers? I mean, these are all really, really important questions for stakeholders. I mean, think agriculture when it comes to MCS activity in the Great Plains and even portions of the Corn Belt here. I mean, we get more severe MCSs and derechos than anywhere in the United States here in Northern Illinois. So, I mean, those are really important. I mean, I don't think it's just the severe weather that, this year, but the pattern that set up this really active period of severe weather also caused significant flooding. And I can say firsthand that coming to back from NIU today, the cornfields are a disaster. And we'll have to see exactly what the impact of the agricultural yield is from this particular setup. But yeah, it's just these are fascinating questions, and we just don't have a lot of answers, because I'll tell you one thing, we do have some answers. I don't want to say like we sit all day and do nothing, and then no, we're actually doing a lot of work. But you do, let me put this in perspective, you do a lot of work to get one answer, and you don't want to put all your eggs in one basket with one answer. When you run these climate simulations down at thunderstorm scale, you want to run them ideally 50 to 100 times to get an ensemble, outcome of what might happen. And until we have that, I think you're always going to see people caveat these answers with, we need more work, we need more research, we need more of this, and I know it sounds like more, but to say anything with high degrees of confidence, we're going to need a lot of people working on the problem and a lot of potential ensemble outcomes to be able to say anything, I think, meaningful.
I totally agree with you. And the last thing before I kick it over to Jared, maybe just one more follow up, especially down here in South Carolina, in the June, July, August months, when you start to get that summer pattern really kick in, I know for me, when I start to notice 500 millibar flow out of the Northwest, that mid-level wind out of the Northwest for the folks at home, that's when I start looking for the MCSs that, like you said, come through your neck of the woods. Then I guess they go around the ridge axis and in the southeast they come.
That's exactly right. Yeah, and I mean, some of the work that I did when I was at Georgia, actually, and others have looked at the future climate of the southeastern United States, and there's not a lot good to say about the climate of the southeast. At least the climate models forecast by late century, it's really just a drying out. And certainly, if you can keep the MCSs riding on top of the ridge, you'll be able to get that precip. But heat and humidity, especially when you see places like Florida setting temperatures in the 90s and in upper 90s and near 100. I mean, that's pretty remarkable from a climatological perspective in the Southeast, where you generally get hot and humid, but not what I would consider desert Southwest or even Northern Plains hot, mid-hot, because you just have so much humidity. It's really hard to do that. So, yeah, all very, very interesting questions, and certainly we'll be investigating those things over the next 5 to 10 year trajectory. But I'm not even sure by then I'll have a really good answer for you. But we might have more pieces of the puzzle, right? But right now we're still pushing ahead.
Well, Victor, you guys are guilty as charged. You sent a pair of MCSs all the way to our coast over the weekend that got everybody all riled up. They didn't understand where did this come from. I'm like, yeah, it came from Illinois and Indiana, and traveled over 1,000 miles in 10 hours and got here. With derecho winds, I mean, it was 65-mile-an-hour winds here. It was
not
impressive
only that,
to see how well it held up over the Appalachian Mountains. It was just wow.
Not only that, but people kind of forget once they get here, they've already probably been out in the Dakotas 700 miles west. They generally start way out there, and Nebraska, or even somewhere up on the high plains before getting here at 2 or 3 o'clock in the morning. They'll get to Indiana, Ohio, the Ohio River Valley. They'll re-strengthen right overnight, and feeding on the low-level jet, and then the next day they're down by you guys. So these are pretty impressive, long-lived MCSs that can occur when you get a strong shortwave to ride over the top of the ridge, and that's exactly what we saw with this last event.
Yep. Victor, we've gotten a lot better at radar over the last 10, 15 years. We've higher resolutions, better temporal resolution in addition to spatial resolution with sails, and soon MRLE, which will be very interesting for operational forecasters. Has that shown any improvements in your ability to find additional tornadoes in the southeast? We get a lot of the QLCS variety, spin up, spin down, that's it. Any effects from that you might have noticed?
Certainly, I think there's more tornadoes going into or being warned on. Perhaps there's also, though, more false alarms. So we're not really sure the impact that, no studies that am I aware of that have really tried to stratify by storm, at least recently, storm type and the contribution of QLCSs to the overall warning climatology in the southeastern United States, and really how that affects the overall tornado climatology. It's probably significant. To what degree? Again, I'm going to have to take a pass on that. But I will say that one thing that's nice about using the significant tornado parameter, right, and getting away from some of these subjective tornado measurements. So, for example, you might have one Weather Service office and one CWA where they have a warning policy that's, as soon as we see it, we don't care. We don't ever want to miss one of these things. We want a perfect probability of detection, even if that means issuing lots of false alarms. You may have the office next door that has a slightly different policy that says, we're going to wait till we think there's really significant potential for damage to lives and property. Could there be a tornado there? Yes, but it's whack-a-mole. I'm going to cover it with a severe thunderstorm warning, right? And then we have the issue of who's verifying our warnings. As we all know, the National Weather Service goes and verifies their own warnings. So if you issue a severe, are you really going to go out into the field and try to verify that tornado happened? I don't know. I'd like to think that they would, right? But we have a lot of those competing factors at play that don't make it as simple as saying, well, yeah, the tornadoes are increasing in the southeast because of more QLCS events. I think that could be part of it. However, when you put that's actually the question you ask is a question that we had from one of the reviewers, and we answered it by saying, well, you could be right. There could be some potential from QLCS events. However, why are we then also seeing, an increase in the significant tornado parameter? So whether it's a tornado or not, it's still a tornado, and we still have the environment supportive of tornadoes. So there's still an increasing trend, even if the types of tornadoes or the types of parent storms that are producing tornadoes are perhaps different than they used to be, or maybe didn't get classified the way they used to be. So you bring up a really good point. But we tried to mitigate that effect by, again, using the significant tornado parameter, which we know is really actually partial to the Great Plains, believe it or not. It's not something that you see super high STP in the southeast, unless it's an April 27 type of event, right? Usually, that index was built for not even forecasting. It was built for diagnostic discriminator between significant tornadoes and non-tornadic supercells in the Great Plains, and really is only valid when there's right moving supercells. So there's a lot of caveats to STP that I think people kind of forget about. But it was interesting that we did see also an increase in significant tornado parameter where we were seeing some of the biggest increases in the southeast. But yeah, bring up great question.
Yeah, and continuing to go through there, looking at the significant tornado parameter, the STP, we keep talking about, for some of the folks at home that may be listening to us, can you talk a little bit about the STP and what it is, what goes into it, and the effective uses?
Yeah, well, again, the first paper that I'm aware of that really started it was Thompson et al. 2003. Rich Thompson at the Storm Prediction Center. He's a fantastic forecaster. He's a lead forecaster there at the SPC. So he's on the desk that's issuing watches. So if you get a severe thunderstorm or a tornado watch for your area, that's coming out of Rich's office down there in Norman. And or other forecasters that are sitting alongside of Rich that have the lead forecaster role. They of course collaborate with the local offices to issue those watches. But Rich came up with that as a diagnostic index, basically saying, all right, we have this environment that's present, not forecast, that's here. Is this environment conducive to a significant tornado or a non-tornadic supercell? And again, it was tested on right-moving supercells, really formulated for the Great Plains. So there have been subsequent indices like the Sherby and other things that have kind of really looked at the forecast problem in the Southeast. Look, forecasters are really good at the long track isolated classic supercells, and we can get warnings out on those 30 to 40 minutes in advance. It's the QLCS, right? The low cape, high shear that are still super problematic from a warning perspective. And those are, again, pretty prevalent in the southeastern United States and create for a very, very, very challenging warning issue. So I don't pretend I know the answer to the southeastern warning problem. I know that, if I were to run the Weather Service for a day, the warning policies would be different than they are now on QLCSs. I think we're maybe not encouraging people to warn on them as much as we otherwise should. There's a lot of people that say we're warning too much on them, but you know what? I've seen this year alone significant F2 or greater damage from QLCS tornadoes in the Southeast and in the Midwest. And they've kind of, and I'll tell you straight up, the latest Severe Local Storms Conference put on by the AMS in Stowe, Vermont, there was a very prevalent forecaster that said these are, a lot of these are QLBS, and I think, that kind of stuck with me as, wow, QLBS, really? We have forecasters that think that they're just BS tornadoes and they're not anything to be, I don't know. I don't agree with that. We have several now case studies and examples that show on the north end of these MCSs or QLCSs, these inflow notches, we have velocity couplets that look like they're from supercells. And I think we probably just need to do a better job training people on what to look for when you're getting these signatures. And I think it probably goes back to a previous comment of, I forget who said it, but how much of these QLCSs are contributing to the overall climatology. I think that's another thing. I think maybe we're just a lot more aware of them now than historically, but they're very, very challenging because, man, you guys know they're often embedded in rain. Look at the storm, even that was approaching Lawrence, or that hit Lawrence, Kansas, and was approaching the KC metro area earlier. I mean, that was no classic. I mean, you saw that from the helicopter. People thought that whole thing was the tornado. No, I mean, that was the low-level mesocyclone that was shrouded in rain, and the tornado was pretty much buried within that. And so you get a lot of these, your perception of a tornado versus what tornadoes actually are. Not that anybody actually agrees what tornadoes really are either. I mean, where does the tornadic wind field start and end? I don't know, but these are, again, you're asking very challenging questions that not a lot of these are things that we're going to continue to struggle with, and maybe even more in the Southeast than other places.
And that kind of leads me into the next question. We get down into Florida, it's a lot more flat land down there, right? So we have like northern Tampa Bay area that's known for tornadic activity. We have the southeast quadrant over the Fort Lauderdale, Miami. Then we have Jacksonville area, of course. That's kind of a little nook in the coastline there where you get a little bit of spin up from time to time. We go north, though, into Georgia. We go into South Carolina, North Carolina. And we look at the systems coming across the Appalachians, and we wonder, why is the Southeast a hotbed for activity or tornadic activity anyways? You'd think it would be more along the coastal plain, but it actually is more upstate and along the Midland Scarp areas where you're seeing a lot of this activity. Can you speak to that a little bit in some detail?
Yeah, that, from my understanding, that climatology and the Piedmont climatology area is completely different too. I mean, you get into places like North Georgia and you get a lot of cold air damming, which actually helps mitigate, or you can get subsidence, but generally you'll get just a really cold, dense boundary layer air mass, and you lack the instability, especially when lows are tracking along the Gulf, right? And you have a high pressure that's situated up in the Northeast New England area, and you're getting cold air damming or wrapping around from the spine of the Appalachians, which makes it pretty difficult to get tornadoes there. But really, the northern extent is mostly wind shear. The season just lasts there longer because you have greater number of days with adequate effective layer shear. In the Southeast, Cape, at least in the spring and summer and fall, is not really an issue. You get into this, winter months, and wherever you have moisture, you can still get it. Generally, it's still, high shear, low Cape. But as you move into the prime time for Cape in the southeastern United States, it's generally not overlapped with the greatest amount of vertical wind shear. So climatology there is a little bit higher due to effective shear. further to the north. But again, you see some very localized, intense setups. I think of, there was it was during the sequence of outbreaks of April 2011. You guys probably know the date, but east of Appalachia there, I think even over by Myrtle Beach, there was a significant tornado that occurred just to the west of that area. And, those types of events can certainly present themselves if the synoptic conditions are just right. But again, they're a little bit less prevalent there than perhaps in some other places.
Yeah, Savannah, Georgia is another hotspot. Tybee Island area. That seems to be a real hotspot. I think that has to do with the curvature of the land, maybe, and some of the river systems that go through there. But you mentioned something earlier about nighttime tornadic activity, and so I want to get your perspective on that. We see nocturnal processes here where we have inversions in the atmosphere. We have sort of a mid-level highway that these storms can kind of travel along. And so we get this nighttime tornadic activity. Talk a little bit about the nocturnal processes that drive that.
So the nocturnal stuff, you generally in the Great Plains, if you think about, let's just take and I'm going to really overgeneralize here. Let's just take a legitimate, like late May, big tornado setup in the Great Plains. It's probably a dry line hanging out west of I-35, strong vertical wind shear overlapping a pretty unstable warm sector. Storms form along the dry line. They go till 7, 8, 9 o'clock in the evening. They produce big tornadoes. The setup's over. That's, and again, they're really respectable, intense tornadic supercells. The big tornado events that happen in the southeastern United States are usually big. I mean, think April 3rd, 74, think April 27, 2011. They're big wound up synoptic cyclones that have so much advection, they're dynamically driven. And so overnight, you may have such strong influx of moisture off the Gulf of Mexico that there really is no nocturnal inversion that's present. The boundary layer never really cools off. It's just dynamic processes that are feeding these parcels into the storms. And with that amount of dynamic forcing and advection, the whole idea of diurnally driven instability is out the window. You replenish that cape, no issues with the strong southerly warm air advection. Those systems, you don't really generally see those in the spring, at least in the late spring. In the central and northern tier of the United States, you just don't get those really wound up lows that you can get in February, March, and April, say east of the Interstate 35 corridor, for example. So those are dynamically driven, and the baroclinic differences, but they're dynamically driven at the heart of them. And the whole idea of what does the clock say in terms of diurnally driven instability, that it doesn't matter at that point when you have such dynamic processes at play.
Do you think elevation has anything to do with it as well? I mean, we picture out west, like you see on TV, you see videos, these giant tornadoes, and the supercells out west are different dynamic than what we get here in the southeast. You have a higher ice core, the base is higher, and then the southeast you just get these low approaching, close to higher elevation with hills, and how does that kind of affect the tornadic activity here?
So the LCLs, right? I mean, when you think of the Great Plains, you see these majestic high LCLs, easy to visualize tornadoes. And you get to the southeast, you maybe have a little bit more boundary layer mixing ratio. So your LCL, you have a greater amount of moisture ability because you're closer to the Gulf of Mexico. That'll generally keep your LCLs a little bit lower in check. And the storms, at least the bases of them are kind of ground scrapers, at least for the big ones. So that's a totally different dynamic, if you will. The physics of the tornado process, we think, are pretty much the same, but there's some research that suggests, elevation can play a role. There's some interesting work out by Dr. Jana Hauser at Ohio that looked at a tornado in Oklahoma with Raxpol that had very high resolution temporal data and could actually see differences in the strength of the couplet through different depths of the layer as this tornadic storm approached and crossed the Wichita Mountains in Oklahoma. So we're going to need a lot more observations for that. I'm not really sure that I have the answer of, how, say, boundary layer. I think I remember actually somebody in SLS presenting a paper of a supercell in a model going over a hill. And on the upside of the hill, there was kind of a decrease in the mesocyclone strength. And on the downward side, where it kind of stretched out, if you think of stretching a column, on the downward side, there was sort of this increase in vorticity due to the conservation of angular momentum. So I think there'll probably be more research to come out about exactly how local scale topography plays. We all know that there's hot spots though across the U.S. in certain areas where the winds will stay backed a little bit more because of friction, perhaps associated with some sort of valley. Those all probably play a role. To what degree on the storm scale? Really hard to quantify that, and even in modeling studies. But observationally, we see it, so we know it probably has some bearing, some degree. The question that I ask though in those studies, well, how can you be sure, right, that the valley or the hill enhanced or mitigated the tornado? And I think that's where a lot of people kind of are like, well, we can run the simulation again with no topography and we still get the tornado. So, right, how big of a deal was it really? We're not, I'm not sure in some of those cases if we actually have the true answer. But again, this is where people are working on these issues, and I have no doubt that we'll probably have more answers here as more simulations continue to get out and more research is done. Absolutely, and I'm going to kick it over to Scotty here. He's pretty familiar with his tornado alley up in his section in North Carolina. They have a real hot spot up there that's a well-known area.
Yeah.
Over to you, Scotty.
Yeah, thank you, Shay. And what Victor is talking about, if you're joining in from Western North Carolina, the column of the storms kind of elongate off of the mountains. There's been some studies. Northern Alabama, I believe, has done a study about featuring Western North Carolina and the little mini tornado alley, as a lot of locals like to say around here. And we've seen a lot of storms produce some tornadoes and a couple of EF3 and EF4s at times. So definitely possible here in Western North Carolina. Victor, you were talking about research. And so as we close this conversation, what's next in this research? What are you guys continuing to look at? What are some of the outcomes that you're wanting folks to know? If you were talking to folks tonight here in the Southeast, what should they know about this study, and what are you guys doing in the next weeks, months, years to come about the research you've done?
So, I don't want to scare people, especially in the Southeast, saying that more tornadoes are more frequent, they're happening more often, but the data is the data. And I think the biggest message is that a tornado can happen at anywhere at any time, regardless of what the calendar says, or regardless of where you live. And you got to have a plan in place, and you can't be thinking about that plan when the house is crumbling down on you. You need to have a plan in place at all times. And that plan should include get to the lowest floor in your home and put as many walls between you and the storm and the tornado as possible. And if you live in a mobile home, when you get a tornado watch, that's probably the time to start thinking about what you're going to do now. Get your stuff, get out of the mobile home, and get to a safe place. The watch is the perfect time to do that, in my opinion. I think we need to really start focusing on the southeastern United States more, and especially mobile homes, and what we're going to do to mitigate injuries and fatalities in that area. So we're going to continue to collect data year by year, keep piecing this thing together. Try to figure out really what the causes are right now. We're not 100% sure of what's causing this change. It could be natural variability. It could be a much larger scale shift that's being induced by changing weather patterns that humans we know are playing a role on. So there's that piece. My sort of research idea and focus right now is really to try to focus on what are the big scale implications that maybe forecasters can pick out to try to diagnose whether or not we're going to get one of these big months like late May 2019. Are there any factors that we can pick out a couple of weeks in advance to understand whether or not we're going into a really active pattern or not? And we've had some success with that, some recent success with that, and we hope to really continue that research forward. This so-called subseasonal to seasonal timeframe, I think you're going to be hearing a lot more about that in the next 5 years as more projects are funded, hopefully, and more science begins to come out in terms of what are the major driving forces of a really active tornado year versus perhaps a not so active tornado year. So that's some of the stuff I'll be working on as we go forward, and I'm excited to keep crossing T's and dotting I's, as they say, in publishing work that hopefully has significant societal benefit. I've always tried to focus on research that makes a difference in people's lives, and that's what we'll continue to do as we go forward.
And so, Victor, as we do that, as you continue to do your research, if folks want to read up on this, they want to continue to follow your research, how's the best way to do that?
So on Twitter, I do, every time we have a study come out, I generally, or my research group will send out a tweet and a link to the paper. And many of them are open source, but some of them are not. So if you do want to read a paper that's behind a paywall, you can always contact an author to get a copy, an author's copy. But my Twitter handle is at Gensini, my last name, GENSINIWX. So Gensini Weather, the shorthand for weather, WX. That's probably the easiest way. That's kind of how I disseminate research to the masses nowadays. But we also have I have a homepage where I have a lot of forecasting tools and sharing information and knowledge there. And that's at atlas.niu.edu, atlas like a map, .niu.edu. And you'll find a whole bunch of stuff on there, like various research and forecasting projects, as well as some of our real-time forecasts from the subseasonal stuff. If you go take a look at that. So if any questions, always just shoot me an email or tweet at me. And I generally try to do a pretty good job of getting back to people if they have questions. So
if you follow weather Twitter, Victor's a great weather Twitter follow. I highly suggest that. Victor, I've been watching some of the numbers on our restreams and stuff, and a lot of people tuning in tonight and a lot of good comments. So we appreciate you joining us tonight, and a lot of people talking about how interesting this topic is. And as you said, the research will continue, and hopefully we'll be able to get more and more answers so folks can be prepared. And like Victor said, you need to make your plan today. And not only with tropical systems and tornadoes, but flooding, we see a lot of that weather, and it's kind of all tied together in one case or the other. You always need to be prepared and not wait until the storm's happening. You need to do that before the storm. So
yeah, I'll just mention very briefly too. I know we're kind of wrapping up here, but whether or not this trend continues is probably a moot point. We know that these disasters are going to continue to occur and probably occur with greater frequency. Think Beauregard, right? Think Birmingham, think Tuscaloosa, think some of the recent events in the southeastern United States. They're going to continue to happen and probably get more frequent just because our cities are growing larger and we have more assets, more targets in the path. And it's really time, to be serious. And it's not just, as you mentioned, and I think that's a great point. It's not just tornadoes, it's hurricanes. If you're in the West, it's wildfires. There's always a hazard no matter where you are. You just need to think about what those hazards are. And, I know it's super hard, but you cannot be complacent, and you really need to have a plan no matter what. So that's my best advice.
Victor, thank you so much for your time. We always enjoy having you as a guest, and I'm sure we'll be calling on you to come on and talk about something else. Stick around if you want to. I'm going to toss it over to Jared Smith, who has some of our weather headlines.
Okay, great, guys. Thanks so much.
Victor, thanks so much. This was awesome. So pretty raucous weekend. I mean, we're talking about MCSs earlier, and look, I'm going to just stir the pot a little bit. I think we got the tail end of a derecho. Saturday morning came through and did a fair bit of damage in the Carolinas. Let me just I have a map of South Carolina. I'm going to share my screen here real quick for those of you who are not on the podcast, who are listening on the podcast. I am getting a look right now at damage reports from the Saturday, June 22nd, the morning storms. You can see all these orange dots here, wind damage. Good bit of wind damage. Especially in Columbia. I'm sure Chris has probably heard some things around there. I saw some pictures out of Columbia that were no good. As that MCS
shooting video at 4 a.m. And I saw a tree go flying down Assembly Street in downtown Columbia, like an entire tree. It was pretty intense.
Yeah. So, and we don't typically see that from even just a regular storms. Chris got some beautiful lightning shots from that and avoided the tree. So all was well there. But you can see we had a fair bit, just a really good bit of wind reports. It got to 52 miles an hour at the Folly Pier. And it produced this. So here's a picture of some wind damage here, some tree branches down. This is from Nick Dilbeck. This was in looks like a very near Park Circle in North Charleston. But then it produced, but as it was moving through, it produced this beautifully striated shelf cloud here. Here's how it looked from Seabrook Island. Thank you to Glenn for sending this and a lot of other great weather pictures along. This one's another one from Nick Dilbeck, and you can see this was as it was approaching him. Do not condone taking photos while driving, but sometimes that's what you just got to. Sometimes you just got to get the shot. So, but yeah, as you can see, it was a pretty raucous morning that Saturday, followed up by another round of thunderstorms that came through in the afternoon. These did a little bit less damage, thankfully, but there was still some, a fair bit of trees down over the last. Really, end of last week, into the weekend, been a bit of a calmer few days in the Carolinas. Just hot, getting into the 90s. So
Jared, we had winds that morning one, 52 miles per hour highest in inside the Charleston Harbor, and then the second one that came through was 65 miles an hour recorded at the Folly Beach Pier. And there was some video of the beach. Folks were actually out on the beach, filming, and 65 mile an hour winds.
Yep, that wasn't smart. I was downtown. I let the shelf cloud overtake me, and it was pretty rad, truth be told. But it was a little unnerving too. But as these can be, but yeah, it was definitely a big few days for wind events after we really had nothing last year. So down here in Charleston and in Charlotte had some similar issues too, for sure. Louis Isolini, National Weather Service Director, is proud to announce the sixth Cosmic 2 satellite was launched last night. So again, some additional satellite firepower, and to help us with our weather models, to help us with space weather monitoring. Where there's coronal ejections coming, I'm sure we have plenty of space weather stuff in the archive there. Go scroll back a few weeks and you'll find a podcast about that. And just the more eyes, the better. NOAA 20 went up last year, and now we have another constellation of satellites. If you follow people like William Churchill or Scott Backmeyer on Twitter, they will be very happy to show you how GOES 16 picked up the heat signature from the launch. So that was pretty cool. And then something interesting that's going on in Mecklenburg County. This is something that we've dealt with in Charleston, and they are looking at buying out a bunch of damaged houses from flooding. And we've had a recent round of that here, not very far from me, maybe a mile or two down the road. And so they are continuing. They are considering a buyout program. You're going to see a lot more of this as flooding becomes more of a problem. And Chris just passed this along to me. I'm going to load this up. I'm going to let this twirl around here as my computer is maxed out. And then we're going to do a little weather roundtable here. June 20th, this was fun. So, if you ever watch any of our severe weather coverage, you'll note that sometimes we're like, hey, treat these as a tornado warning. Just because the wind is straight doesn't mean it can't do damage. And sure enough, National Weather Service in Columbia surveyed 110 mile an hour straight line winds from a cluster of thunderstorms on June 20th. So this was a survey of straight line wind damage. And those are your paths. And here's just some of what that looked like. And again, twisting gets all the headlines, but the straight line stuff is just as bad. I feel very sorry. This is very unfortunate for a lot of people who just, severe thunderstorm warning seems like a dime a dozen, but no, these are serious. And you can see a fair bit of destruction here. I mean, again, 110 miles an hour, that's EF1 tornado damage. That's closing in on major hurricane strength. That's Cat 2. If you think about, what that's like on the Saffir-Simpson scale, obviously not sustained in a thunderstorm like this, but some pretty serious stuff. Scotty, back to you.
Thank you, Jared. I know you previewed the weather roundtable. We'll get to that in a minute. I think the weather's going to be fairly calm over the next few days, but I wanted to talk about this. It kind of pushed my buttons a little bit. Victor was talking about the QLCS tornadoes, and where some research was, some of the researchers are calling it QLBS, and that kind of perturbed me a little bit because this is a real threat that we face in the Carolinas. Victor, I'd love for you to jump in on this, and Evan, you and Chris, as well, everybody, honestly. It tends to be, especially in Western North Carolina, Evan, you can attest to this. Midlands, upstate South Carolina, we see these QLCS tornadoes more than we would supercell tornadoes, and that's the threat, honestly, that we face a lot here in the Carolinas. So please, for those folks who think those are just BS storms, it's really not. And in fact, Evan, you and myself and Chris, when we were chasing, we stayed in El Reno. And our hotel that we stayed in was about, I don't know, a half a mile away from the QLCS tornado that went through May the 24th, I believe, maybe early May 25th. And it was on the ground for a short amount of time. But I believe, if I'm not mistaken, that was rated EF3. And we saw the damage. And guys,
I think it also produced a fatality.
Yeah, it was a fatality in the hotel. These are things that you've got to pay attention to, and so I'm always err on the side of safety. And if you issue a tornado warning, on those QLCS, it's better safe to be sorry. And we saw firsthand, honestly, 4 or 5 days later after it happened, but the damage was still there. Evan, Chris, I think there was 3 or 4 dealerships that were affected. That still there that we saw. I mean, there was a lot of damage in that small section, and like Victor said, there was actually a fatality there as well.
Yeah, I mean, I was watching on radar as it happened, and I saw that QLCS coming into the metro, and then you start to see that inflow notch on the top of that line, and I'm like, oh boy, here we go. And sure enough, between one scan, you barely had any kind of velocity couplet to a full blown mile wide TDS in less than 2 minutes. And it's so important for people to understand that in a QLCS, there's I'm going to say a very good, but there's a better than average chance that a tornado could develop before the radar even sees it. And so that's why it's so important to stay weather aware and to know it. If you're under a tornado watch or conditions are getting really bad and there's a possibility for tornadoes, to have a plan in place. It's so important. Like you said, El Reno. Being able to go over the overpass on I-40 and see the wheat field that was just about 200 yards west of that hotel that was, utterly destroyed. A 2-story hotel. There was nothing but bricks left. But that tornado literally dropped in that field, and it wasn't but maybe 30 yards wide. But where it was 30 yards wide, the wheat was missing. And it's just incredible to see that.
Well, what Chris just said, I think, is one of the biggest dangers of those storms, because a lot of times those storms come without warning, unfortunately, or within 90 seconds to 4 minutes of a warning, just because they spin up so quickly between scans that they're so undetectable. And I think for a lot of the public, when you see a tornado warning, you think, okay, it's time to act. But if you have to get a few things together before you can go down into your basement, a few things could mean 3 minutes, and you may not have 3 minutes. It's one of those things where you have to have your plan in place ahead of time, just like Victor was saying before, and Chris and Scotty.
To me, guys, I honestly, I think I can't say enough good things about the National Weather Service and the warnings that they put out, whether it's severe. I know people don't generally take severes seriously, but severes and TORs. But I keep going back to this. I keep telling people, don't wait for the warning. When there's a watch, right? How much of this stuff actually happens outside of a watch? Not a lot of it. Most of it's in a watch. So if you are under a watch, whether it's severe or TOR, conditions are favorable for TORs. And that's just the way it is. If it's a severe thunderstorm watch, even if there's a severe thunderstorm bow echo, there can still be conditions favorable, right, for producing tornadoes. So whether it's a blue box or a red box, I'd keep telling people that, conditions are favorable for severe thunderstorms. Severe thunderstorms can produce tornadoes. That's the definition in the United States, right? A tornado is a part of that. And so really try to make sure people understand in the watch phase that any storm inside of that watch or even near that watch has the capable of producing damage to lives and property. I think that's the message we need to start sending to people.
And I think, and hats off to the Radar Operations Center and the radar technicians. Absolutely. And everybody who does that. Sales 3, you getting updates every 75 seconds at the lowest tilt of the radar. That's changed so much in in detecting these things and giving whatever lead time we can squeeze out of it. That's been fantastic. And then, and now that they're going to expand the sales concept to more of the mid-level tilts too, so we can see more of those. Hopefully, that means we can start to see a little bit more early detection on these. But yeah, I mean, they're dangerous. I mean, they're dangerous because they are so unpredictable.
And to echo what Victor was saying about the National Weather Service, they do a great job. And I know here locally with the forecast offices that we work with, and guys, we've done this in severe weather coverage this year, there's a lot of severe thunderstorm warnings that has the tornado possible tag. And that kind of also, it'll say severe thunderstorm warning, 70-mile-per-hour wind gusts, tornado possible. And so that also, as Victor was talking about, you need to take these severe thunderstorm warnings just as important as tornado warnings. And then, that warning, that tag, tornado possible tag, could account for a quick spin up in these QLCS situations. So definitely take those seriously. So I want to get over to Shay right quick. Chris has got one more thing, and then we're going to toss to Shay, and he's going to kind of give us a quick tropical update, and then we will close for the night. Go ahead, Chris.
Actually, I'll tell you what, I'm kicking Shay. Shay, go ahead.
Oh, you sure?
Yeah, go.
Okay, yeah, I've got to hop off here in a minute. Wanted to go ahead and do a quick tropics update. Let's share screen, and you can see basically what we have is we are way over here, just entering July. So we haven't even gotten into where we start to see the uptick in the tropical activity. Things are generally pretty quiet this time of the year. That's reinforced by this right here. So no tropical cyclone is expected during the next 48 hours, nor in the next 5 days. So we're looking pretty good there. Meanwhile, over in the eastern North Pacific, we have our first storm of the year, which is actually running kind of late, which is Alvin. This is not expected to last very long. Probably will weaken back into a tropical depression in the next 24 to 48 hours. But either way, that's the first Pacific storm, and the Atlantic Basin is all quiet for right now. A lot of this has to do with upper shear loft around many parts of the ocean. Also, tropical cyclone heat potential hasn't really spread very much outside the Caribbean, except maybe near the loop current around the Yucatan Peninsula area. We also have this right here. This is from a couple of days ago, but this is kind of the trend of what's been going on. What you're seeing here is the SAL, or the Saharan air layer, where you have mid-levels of dust just training across. We call this the dusty tongue of the Saharan desert, and this is why I picked this run, because you can clearly see it right here. Some of those have been sort of breaking off and heading over the Gulf. There's been a lot of talk in the media about it. So this also helps keep the atmosphere dried out. You don't get a lot of moisture built up with this. So the monsoonal trough is just south of this, but it's not enough to really get any waves to form. Even in the Western Caribbean, where sometimes you get moisture pile up, we're not seeing that either, because that Saharan air layer is over that area as well. Until that relaxes a little bit or drifts a little further north, we may see a couple of tropical waves sneak in under that over the next couple of weeks. But right now, nothing is really occurring over the tropics. So we're pretty quiet for right now, and we'll take that as far as we're concerned. We don't really want to see any activity, but we do expect to see near average to slightly above average storms this year. And it only takes one. Remember, it only takes one large storm or a very damaging, like we saw Florence last year, to change that perspective on a season, to go from non-active to active.
All right, thank you for that, Shay, and we appreciate that. If you need to jump off, by all means, go ahead. Chris, I know you had a follow-up thought, and then we'll the show tonight.
Yeah, just one final thought about the tornado thing, and really preparing for tornadoes and having a plan in place. Something that we saw when we were out in the plains, and it's the first time I've actually seen it. We were on one storm, and there was a big tornado. It was out near Tipton, Kansas, and it had a big wedge tornado. It was about a half a mile wide, but at one time there was 3 tornadoes on the ground within probably 5 miles of that storm, all from the same parent storm. And the radar just, being that distance away from the radar site in Hastings, Nebraska, it just couldn't resolve that kind of detail needed. And so on radar, you couldn't see that. But I know Skip Talbot's got some great video of all 3 circulations at the same time. I've got a bunch of stills of 2, but I don't have the 3. I think because we were driving to reposition. But it's just so important. Anytime severe weather approaches, have a plan in place, because there's just things that can happen that the radar might not even be able to see.
And we know all about that radar hole here in the Carolinas. It seems like that's where all our severe weather kind of likes to congeal together. So we hope you enjoyed tonight's conversation. If you're watching here on the YouTube Live and you want to listen to this again, you can find us on Spotify, on the Apple Podcast, Google Play, as well as Anchor FM. And on Anchor FM, you can hear a lot of our different replays. So we encourage you to download those and follow us and subscribe to us, as well as on our YouTube page. Next week is our off week. We're going to be celebrating the 4th of July with our friends and family, but we will still have a show for you. As of right now, the plan is to air the National Hurricane Hunters media day. That's what we went to. I was trying to think of the words, but myself, Evan, and Chris was able to catch up with some of the folks from the National Hurricane Center and tour the aircraft and kind of talk about the hurricane season, upcoming hurricane season, and the effects on the Carolinas. So the plan right now is to play that. We want to send our well thoughts and well wishes to James and his family, as there's his mother-in-law is battling some illnesses. So that's why James is not with us tonight. So if James can get that turned around, we may have that plan. If not, it'll be a rebroadcast. But our thoughts are with James and Chelsea and everyone down there, and hope that everything turns out all right. After our little 4th of July getaway, we'll have Ed Piotrowski on with us July the 10th, and we're going to be talking about all things in Myrtle Beach, all the weather that Ed has covered. I'm sure Hurricane Hugo will come up, as well as the July 7th, 2001 tornado that was very photogenic right off the coast of South Carolina and then moved inland. So we'll talk about that with Ed, as well as many more things that's been happening in the Grand Strand and the PD over the last several years. So that is our show. We hope you enjoyed it. As always, click subscribe if you want to leave us a rating. We'd like that as well, and just share our name out there. And if you have any guests or potential topics you'd like for us to talk about, send them our way, and we will try to get that worked on. So for everyone, the Carolina Weather Group, we hope you have a great weekend. Have a safe and happy 4th of July, and we'll see you back here for another live edition on July the 10th with Ed Piotrowski from WPED in Myrtle Beach, South Carolina.